The following data are obtained when dinitrogen and dioxygen react, oh my God, together to form different compounds. Well, we have N2 and O2 reacting with each other to get different compounds. Fine. 14 grams, it reacts with so many grams of dioxygen. Then 28 and 28 give you with so many mass of dioxygen. Which law of chemical combination is obeyed by the above experimental data? Give its statement. Fascinating. Now, I can see that the compounds seem to be different. Why? Because 14 grams are combined with 16 and 14 again are combining with 32. Same mass of dinitrogen seems to combine with more than one types of masses of oxygen. This hints very clearly at more than one compounds, which means law of multiple proportions. So data 1 and 2 indicate law of multiple proportions. Now 28 and 28 grams if I take. Now 28 grams are giving me 32 grams. If I cut this to half, so 14 grams will give me 16 grams. So this is just, if you look at 1 and 2, they give you multiple proportions. If I take 1 and 3, they are giving me law of constant proportions. Why? If 14 reacts with 16, the double 28 would react with the double 32. That is law of constant proportions. This 14 gives me 40 grams. Oh my God, that's even worse. So 1, 2 ka 4. 1, 2 and 4 if taken together exhibit law of multiple proportions, while 1 and 3 if taken together exhibit law of constant proportions. So which law of chemical combination is obeyed? There are two laws actually which are obeyed. Law of constant proportion seems to be minor here. Major law is law of multiple proportions. What about the statement? I'll tell you the statement also. If two elements react and they produce more than one compounds, if two elements react to give more than one compounds, sometimes they're giving compound 1, sometimes compound 2, sometimes compound 3, that way, then the ratio of masses of the other compound, which combines with a fixed mass of a given compound. So what does law of multiple proportions state? It says that if two elements combine to form more than one compounds, then if I take fixed mass of one element, and measure different masses of the other element then these masses M1, M2, M3 are in simple integer ratio. They are in simple integer ratio. Then they are in simple integer ratio. Like if you see here, the example is with 14 grams, that is the fixed mass of nitrogen. If with 14 grams of nitrogen, different masses of oxygen are combining, M1, M2, M3, leave out the third data, which is useless here. So they are in simple integer ratio, which is being told this is 2, this is to 4, this is to 5. This is law of multiple proportions. Fill in the blanks in the following conversions. 1 kilometer, how many millimeter, how many picometer? Very interesting. Can you convert? Yes. Now, millimeter, how much is millimeter? Millimeter is actually 10 is to minus 3 meters. Okay. And 1 kilometer is how much? 1 kilometer is, kilo stands for 10 is to 3. The 1 into 10 is to 3 meter. Okay. And if I have to get this unit somehow, what do? I say this is 10 is to 6. Sorry. Yeah, let this 10 is to 3 remain as it is. I'll just say it is 10 is to 3 into, now I need 10 is to minus 3 meter. So can I say this? 10 is to 3 into 10 is to minus 3 meter. This is just 1, right? So this is just 1. So 1. I'm just writing this. 1 meter. Are you fine with this? And since this number is millimeter, now what will I do? I'll simply state that this is, and combine this, 10 is to 6 millimeter. 3 plus 3 is 6. If numbers multiply, powers can add. Is that simple? Yes. Do I have to mug up a formula? No, I don't have to. It's common sense. Oh, what did you do? Well, you watch this here. Picometer. Now, see, the thing is, always start with where you're going. Picometer, how much is pico? Pico is 10 is to minus 12. Now, picometer is 10 is to minus 12 meter, right? I could say that 1 kilometer, please understand, kilo means multiplied by 10 is to 3. So this is 1 multiplied by 10 is to 3 meter, which is 10 is to 3 multiplied by 1 meter. Meter also you should consider as something which is multiplied. You can bring it up and forth and back. Now, can I say that 1 is same as 10 is to 12 into 10 is to minus 12? Same powers plus and minus if I take, they will cancel. I'll get 10 is to 0, which is 1. And why would I do that? I would do that simply because I know that this number is picometer. So I would be left with 10 is to 15 picometer. Oh wow, this is how I convert? Yes, this is how I convert. Is that simple? That's very simple and very valuable also. Please note, you find it very useful at times. How about the opposite? If I have a small thing and I want to get big things, I could do that. 1 milligram, let me start with this. 1 milligrams is 1 into 10 is to minus 3 grams, which is 10 is to minus 3 into 1 gram. I just exchange them, ting, tang, right? Now, 1 gram, I have to convert this to kilograms. Now, kilo is 10 to the power plus 3. So, I feel like having 10 raised to plus 3 here. So, I could also have 10 raised to minus 3 so that this on multiplication will give me nothing but 1, right? Okay. But I know that this is kilograms. This is 10 raised to minus 3 into 10 raised to minus 3 kilogram. Oh my God, this is 10 raised to minus 6 kilograms. Yes, this becomes 10 raised to minus 6 kilograms. Okay. What about nanograms? N, nano stands for 10 raised to minus 9 grams. Oh, what would I do? That's not very difficult. I'll again sing the same song again with a different tune. How do I start? 1 milligram is equal to 1. Now, milli stands for multiplied by 10 raised to minus 3. Gram also, just take it as multiplied by grams. Imagine this also is unit also being multiplied. That's it. That's the trick of doing it. And you may or may not write multiplication sign later. That's okay. That is the maths rule. Instead of 1, now I have to write 10 raised to minus 9. How will I do that? instead of 1, I will say this is 10 raised to minus 9 into 10 raised to plus 9 grams. Right? Now, this thing is nanogram by definition. So, I get 10 raised to minus 3 plus 9 nanograms, which is 10 raised to 6 nanograms. As simple as that. 1 ml, milli stands for multiplied by 10 raised to minus 3 liters. Fine. And 1 liter, by definition, my dear remember, is 1 decimeter cube. That is the definition of liter. 1 liter is 1 decimeter cube. So instead of liter, if I write decimeter cube, so this is simply, because liter is same as decimeter cube, 10 to minus 3 liters or 10 to minus 3 decimeter cube. This is a very valuable but a very simple conversion. But this technique is very important. Make sure that you have learnt it.